In this video, we'll be answering 4 questions involving the manipulation of surds. In this first question, we have to evaluate this expression here. We have one surd in a bracket multiplied by another. The steps are the same as when you multiply just two, or expand two brackets that are multiplied together. So we multiply the two first terms. 5 times 5 is 25. We'd multiply the outside terms. 5 times negative root 2 is negative 5 root 2. Multiply the two inside terms. 5 times positive root 2 is 5 root 2. And we multiply the last two terms, so it's root 2 times negative root 2, which is negative 2. Remember, the definition of a square root is the number times itself. That gives you that number. So let's just rewrite those terms together. We've got 25 take away 2 plus 5 root 2 minus 5 root 2. You can clearly see that these two will cancel each other out. And then 25 take away 2 is equal to 23. And that is your final answer. On question 2, we have a similar expression. It says expand and simplify, and then gives you an answer in a particular form. It wants it in this form here, a plus b root 2, where a and b are integers. So let's do the expansion first of all. So we have 3 plus the root of 8, 4 plus the root of 2. Multiply the two first terms. 3 times 4 is 12. The outside terms, 3 times root 2 is 3 root 2. The inside terms will give us 4 root 8. And the last two terms, which is going to be, looks confusing, let's just write it as it is, root 8 root 2. Now root 8 root 2, what is that equal to? Well, that's the same as the root of 8 times 2, which is equal to the root of 16, which is equal to 4. So I'm actually going to replace that with 4. So let's write down the terms that I've got. I've got 12 plus 4 plus 3 root 8 plus 3 root 2. That gives me 16 plus 3 root 8 plus 3 root 2. So going back to the question, it wants it in the form of a plus b root 2. I have my a here, that's a 16, but I have this strange thing going on down here. It's not in the form of something root 2. If I analyse this term here, 3 root 8, I can see that 8 has 4 and 2 as factors. So I can rewrite this as 16 plus 3 root 4 times 2 plus 3 root 2. So that's going to give me 16 plus 3 root 4 root 2. I can split the root up, plus 3 root 2. Hopefully you can see then that that is going to give me 16 plus 3 times the root of 4 is 2, root 2 plus 3 root 2. So finally I'm going to get 16 plus, I have 8 root 2 here, plus 3 root 2 here. So that is 16 plus 11 root 2. Question 3 asks to rationalize the denominator. So that's a technique you use to remove the root from the bottom of a fraction, and you may well end up with a root on the top. Let's have a look at the first one. We have 12 over root 3. So if you have something like this, you simply multiply the fraction by the root top and bottom. If I multiply by root 3 over root 3, that is equivalent to 1, so I'm just working out an equivalent fraction. That gives me 12 root 3 on the top. Root 3 times root 3 is just 3. And then 12 divided by 3 will simplify to 4. So I have an answer of 4 root 3. That's the easy one. For B, we have this situation here, 3 minus root 2. I'm going to put it inside a bracket like that. And what I'm going to do is I'm going to multiply by what we call the conjugate of that denominator. So I'm going to write the same denominator but change the sign. It's a negative sign in the middle, so I'm going to make it a positive sign. If it was a positive sign in the middle, I would make it negative. We do this because then this helps cancel out some of the terms. So what I now have on the top is 3 plus root 2 over, And now I need to expand out the bottom here. So I have 3 times 3, which is 9. 3 times root 2 is 3 root 2. Negative root 2 times 3 is negative 3 root 2. And negative root 2 times root 2 is negative 2. You can see clearly now that these two terms will cancel, which means there are no roots left on the bottom. The top stays as 3 plus root 2. On the bottom then I'll just have 9, take away 2, which is 7. And finally, we are given a statement here that 10 minus the root of 32 divided by root 2 is equal to a plus b over root 2, b times root 2, where a and b are integers. Find values of a and b. So basically, I just need to turn it from this form into this form. So 10 minus root 32 over root 2. I will rationalize the denominator, so I'll multiply the top and bottom by root 2 and root 2. So at the top now I will have, I'm going to write it like this, root 2 multiplied by 10 minus the root of 32 divided by 2. And what do I have from here? Well, I will have 10 root 2 minus root 2 multiplied by root 32 all over 2. So I've expanded the top. That's going to give me 10 root 2 minus, so I have two roots, I can multiply the two terms together, so that's going to be minus the root of 2 32s is 64, all over 2. That's going to give me 10 root 2 minus the root of 64 is 8, all of that is divided by 2. So now I'm going to divide both of the top terms by 2, I'm going to get 5 root 2 minus 4. It wants it in the form of a plus b root 2, so I'm just going to swap the order around, which is negative 4 plus 5 root 2. And just for clarity, I'm going to say that a equals negative 4 and b equals 5.